Hello, hello, honors. Let's finish up your review. Okay, number 30. Determine how many solutions are in each system. That is not what the question says. I don't know why I reworded it, but that's fine. The way we're going to do this for letter A is with substitution. So what I'm going to do, since I have a y equals, I'm going to substitute that in for the y below. So we have 6x plus, in parentheses, instead of y, negative 6x plus 4, and it equals 4. So I plugged that in to my second equation. Okay, well, it looks like the parentheses weren't really needed here because we are going to distribute a positive 1. So I'm just going to go ahead and rewrite this without parentheses. Okay, on the left side, 6x's minus 6x's make the x's go away. So we're left with 4 equals 4. This is a true statement, and because it's true, that means we have infinite solutions. And let me write the infinity symbol. So true, infinite solutions. We're going to do the same thing for letter B. We have a y equals, so I'm going to take this and plug it into that second equation. So we have 2x plus, and instead of y, negative 2x plus 9, and that equals negative 9. Now, once again, we don't really need the parentheses because the invisible 1 is in front of it, and anything times 1 is itself. So I'm just going to go ahead and rewrite this without parentheses. On the left side, you should notice again that your x's cancel because 2x's minus 2x's, no x's, which leaves us with this statement, 9 equals negative 9. Does 9 equal negative 9? Absolutely not. I hated leaving that equal sign just hanging out there. I want to cross it off right away. This is a false statement. This means no solution. Okay, onwards to 31. Let's solve each system of equations by substitution. What we were just doing. So we have a y equals in letter A. Let's plug it in for y. It looks again like there's a plus sign, so I'm just not going to put in those parentheses this time, because you saw me do that in those previous problems. Okay, so I substituted y with 5x minus 4. Okay, what should be our next step, except for putting a line down the middle? Hopefully you thought combining like terms. And we have 6x's and 5x's. That gives us 11x's minus 4 equals 18. What do you think our next step should be? If you thought plus 4, you are absolutely right. So we are left with 11x equals 22. And what's our last step? Dividing by 11. Okay, now that we found x, we still have to find y. And luckily for us, we have a very nice y equals equation. So instead of y equals 5x minus 4, I'm going to plug in that 2 for x. So I'm taking this x equals 2 and plugging it in. All right, that goes straight into my calculator, 6. So my solution is 2, 6. Remember, it's x comma y. Letter B is another substitution problem, another y equal, whoops, that didn't switch over to the highlighter fast enough. Let's take that y equals and plug it in. So we have 7x minus 2x minus 8 equals 7. So I'm plugging it in here. It's a positive y, so nothing really changes there. I'm going to draw a line down the middle, and you think of the next step. If you thought combining like terms, you were correct. 7x's minus 2x's is 5x's. Bring down the minus 8, and that equals 7. What's the next step? Next step is adding 8 to both sides. Okay. On the left, we have 5x, and on the right, 7 plus 8 is 15. And what's our last step? Divide by 5. So, x equals 3. Okay, we have x, let's find y. We have that wonderful equation again. the one that we used to substitute. And remember, we're going to take that 3 and plug it in instead of x in that original first equation. And then all that goes into your calculator to get negative 14. So our answer is 3, negative 14. All right, number 32, solve each system by linear combination. Now, when I look at these systems, the first thing I look for is one of the variables, either the x's or y's, to have a plus or a minus. Now, it looks to me that the y's currently have a plus and a minus, so plus 5y minus 2y. So I'm going to do something to it to make those y's cancel. What do you think we should do? Well, what I'm going to do to cancel those y's is I'm going to multiply the top equation by 2 and the bottom one by 5. So the bottom one by the top number, top one by the bottom number. All right, let's see what we get as a result. 2 times 2x is 4x. 2 times 5y is 10y equals negative 14. And the second equation, 5 times 6x's is 30x. 10y minus 10y and 150. All right, we have opposites. That means we can do linear combination, which is adding. So let's do it. Our y's cancel. That was the point of us doing this. So I'm just going to go ahead and cancel them right away. 4x's and 30x's give us 34x's. And 150 plus negative 14 is 136. Let's divide both sides by 34 to get our x. X equals 4. Now to find y, you really could use any of the equations that you feel like using. What do I feel like using? I feel like using the top one right now. Why? I don't know. Why not? Sorry. So instead of x, which we got as 4, in the top one I'm going to plug in the number. So 2 times 4 plus 5y equals negative 7. I always recommend using the original version of the equation. Okay. 2 times 4 is 8. Oh, I forgot the line down the middle. All right, what should our next step be here? I'll subtract 8 from both sides to start. So we're left with 5y equals negative 15. And what should our last step be? Divide by 5. Okay, y equals negative 3. So our answer for negative 3. Let's do the same thing for letter B. So again, look for the variables that possibly have opposites. Do you see them? I see them in the y's. What should we multiply the top equation by? And what should we multiply the bottom equation by? Hopefully you said or thought to multiply the top equation by 3 and the bottom one by 6. Okay, let's rewrite these new equations. 3 times 5x is 15x. 3 times 6y is 18y. 3 times 35 is 105. 6 times 10x is 60x. 6 times minus 3y is minus 18y. And 6 times negative 5 is negative 30. We have opposites. Let's add. We made the y's opposite on purpose, so they're going to cancel. That was the point. 15x's plus 60x's gives us 75x's. And 105 plus negative 30 is 75. What should our last step be? That's right. Divide by 75. X equals 1. Wonderful! So we could use any of the equations to plug that into. I like to use the original ones. I think that's a better choice just because they're generally smaller numbers. I'm feeling like the first one again, because why not? So I'm going to plug negative 1 into x for the first equation. So 5 why did I say negative 1? I have no idea. Positive 1. 5 times 1 plus 6y equals 35. All right, 5 times 1 is 5. So I'll rewrite that. What should our next step be? Yes, let's subtract 5 from both sides. 6y equals 30. And let's finish up with division. Okay. Y equals 5. Wonderful. So our answer for this problem is 1, 5. Onwards we go. Number 33, write an inequality to represent each equation. That represents, why am I rewording this? I don't know. You're just going to have to go along with it. So here we have a wonderful graph. The first thing I notice is that it's a dotted line. So that means I'll have I won't have a line underneath my inequality symbol. I do know that I need to keep in the form y equals mx plus b. So there's my y. Y is just y. Let's find the slope. I'm going to use 2 points, okay? So go up 2 to the right 1. So our slope is 2, and our y-intercept is positive 1. Okay, now we decide what symbol we're going to have. The way I do it is I draw a straight line up from the diagonal that we have. So, and I'm going straight towards the shaded area. So I'm going to put my pencil on the y-intercept. Let me get a different color. And I point straight towards the shaded area. It's going up. Up is greater than. That's it. All right, letter B, same idea. We have a y, an mx, and a b. Let's find the slope, y-intercept, and decide which way our symbol points. Okay, now I have a solid line. That means I know my symbol is going to have a solid line underneath it. Let's find our slope. Here are 2 nice points to use. It looks like I'm going 1, 2, 3, down 3 over 1. So negative 3x. Oh, why is that so far away? Let's move that. Negative 3x. And our y-intercept is 4 plus 4. Okay. To find out which way my symbol faces, just like before, I'm going to put my pencil on the y-intercept, and I'm going to draw lines straight up or straight down, depending where the shaded area is. I'm going to draw an arrow straight up, because that's where the shaded area is. So our symbol is greater than or equal to. Okay, let's continue. 34, circle all the points that are solutions to the graph system of equations. Okay, so 34, letter A, negative 4, 0, let's find that point. Negative 4, 0 is right here. Okay, that doesn't exist. 0, negative 4. Ooh, that lands on the dotted line, but remember, dotted line do not have or equal to, so we can't count that. Letter C, negative 2, negative 2. Ooh, negative 2, negative 2 lands on the solid line. That means it's part of our solutions. Letter D, negative 4, negative 6. It's in the shaded area. Perfect. 4, 1. It's on the solid line, but that solid line is not part of our shaded area, so no. 0, 0. That's not even close, so no. All right. Next we have 35. What's the common ratio? So the way we find our common ratio, R equals, we do the second term divided by the first term. So 2 divided by negative 4. 2, negative 4. And that gives us negative 0.5 or negative 1/2. There's our common ratio. 36, write the following function in explicit form. Okay, so for explicit form, we need 2 things. We need R and we need A. So our R, our common ratio, happens right here. It's 4. Let's find A. In order to find A, we plug 0 into our exponent. Whoops. So we plug 0 into our exponent. This goes into your calculator. Click, click, click. You should get 0.05. Okay. Our explicit form is as follows. AN equals A times R to the X. So we can rewrite that as 0.05 times 4 to the X. Number 37, rewrite the function f of x equals 7 to the power of x with these transformations. All right, horizontal translation of 2 to the left. Now it's very weird, but left and right are opposites when we think about writing them in equations. So 2 to the left gets a plus 2 in the exponent. A vertical translations up 3 is a plus 3 outside of our function. Letter C, a horizontal translation 4 to the right will be a minus, oh, there's a bell, sorry. Will be a minus 4 up in the exponents. And lastly, a vertical translation 5 units down will give us a minus 5 outside. Okay, wonderful. So I think the biggest thing to remember is that left and right are opposites in this case. Okay, 38. The population of bears in Alaska in 2020 was 30,000. The population is decreasing at a rate of 0.2%. Let's write an equation. Okay, so first we need to write down what we begin with. 30,000. Then we have a parenthesis and a 1. We decide whether it's a plus or minus depending on if we're increasing or decreasing. And it looks like I'm decreasing, so I have a minus. And then don't forget to convert your decimal into a percent. Whoops, your percent into a decimal. So 0.02 divided by 100 to make it into a decimal, oh my goodness, is 0.002 to the power of t. And of course, we can simplify it by subtracting the inside to get that. Right. Number 39. Edgar deposits $5,000 into a compound interest account, paying 3% annual interest. Write the function to represent the balance over the time t. Okay, so if we're depositing money and gaining interest, that means we are adding, we're growing. So first we begin with 5,000. And then we have 1 plus, because we're growing our money. And 3% as a decimal is 0.03 to the power of t. We can also simplify this just a little bit to make it 5,000, 1.03 to the power of t. 40. Amber deposited $750 into an account that earns 2.35% compound interest. How much will be in her account after 8 years? Okay, let's kind of set it up like we did the previous problem. 750. Again, she's gaining money, 1 plus. 2.35% is 0.0235. And we have 8 years this time. So we have a number to plug into t. Let's color code. I don't know why I haven't been. I'm so sorry. And 8 years. All right, all of that goes into my calculator. And after 8 years with this percentage, she will have $903.16. I think she should probably invest in something rather than just keeping it in the bank. All right, honors, last problem for your review. The graph represents an exponential function that models the relationship between the temperature of a grilled hot dog and the time in minutes. At about how many minutes after the hot dog started cooling will its temperature be 130? Okay, so I'm looking for 130 on my graph. It's not written down, but it's right here. Boop. And I'm going to draw a horizontal kind of dotted line until I hit the curve of my graph. There it is. There's 130. Let's find out what minute that is. Oh, Right there, 3 minutes. Okay, that's it for your review. Happy studying. Good luck. Have a wonderful rest of whatever day it is for you. Bye!